Okay, so those of you who are at home, you're going to want to make sure that you have your Newton's third law worksheet out in front of you or open. So where we're at today, we were talking about a jumper and earth, and it says label any force pairs that occur in your diagrams. So yesterday we left off in the act of jumping. Today we're going to start off right after our body leaves contact with the floor and we are on our way up. We just have one thing in our system. What is that one thing that's in our system? Yes, we will get to that, but what's the thing in our system? Not the force, the thing.
Your body.
Your body or you. Yes. So we're looking at our body or you. So once we've left the ground, what is the only force that we are going to experience? There's only one. We left the ground. Gravity. What direction is gravity?
Down.
Down. We've left the ground. There is no other force except for gravity when we are midair. So force of gravity pointing downwards. Who deals the force of gravity? Earth. Who feels it? The person or you. That's it. There is no force applied because you already have left ground. You already had that force applied push you upward. Okay? You should have already had your force applied upward for the person earlier. So in letter A, we had that upward force. All right. It says repeat this situation for the same point on the way down before you have reached the ground. So we're mid-air, we've gotten to the height of our jump, and we're starting to fall back down. We're almost to the ground, but we're still mid-air. What force do I have in that instance? Just gravity. You got it. Force of gravity. Who's dealing it? Earth. Who's feeling it? Perfect. Awesome. Super hard? All right. Letter D says, repeat the situation after you hit the ground and your bent legs are slowing you down. Repeat the situation after you just hit the ground. So we landed and our legs are bending to slow us down, right? We just landed, my legs are bending to slow me down. What things are in our system once we've landed?
Force gravity.
Things, not forces. System.
Your body.
Our body and the floor. So we've got you. Oops, got it right. We've got you. And we have the floor. For you, what is a force that we are experiencing? Gravity. Force of gravity. Who's dealing the gravity? Earth. Who's feeling it? All right. Our legs are slowing us down. Are our legs giving a force then? They are. They're slowing us down, so they're pushing against us. Our legs are actually going to give us a force downward. Okay? So it's going to be an applied force downward. Okay? So we have an applied force downward. We also have a normal force upward. Dealt by the floor, felt by the person. This one will be dealt by the person, felt by the floor. Looking at the floor. What is the floor experiencing?
Floors downward.
Not downward. The floor is to hold you up, right?
Yeah.
So
Upward.
upward, yep. So the floor is going to have a force of gravity dealt by the earth, dealt by the floor. It's also going to have an applied force upward and a force normal upward. Force normal, force applied. The applied force is dealt by the floor, upward, felt by the person. Our pairs are going to be this upward applied force and this downward applied force. That is our Newton's third law pair. All right, so letter A. We've got constant velocity, and we have a block that is 50 grams and a block that is another block that is 50 grams. So it wants us to draw a force diagram for block A, block B, and for the system. So we're actually going to be drawing 3 force diagrams for each of these systems. So I'm going to do A in red, B in blue, and we'll do the system in black, but that'll be later. So for letter A, there it is. Or for block A is going to have a force of gravity downwards. And this actually, because we know that it's 50 grams, 50 grams is the same as 0.5 newtons, okay? So that is 0.5 newtons. So our force of gravity downwards is going to be 0.5 newtons, okay? Earth is dealing that, and block A is feeling it. Do we agree? All right, what's going to be my upward force on block A? It's going to be 0.5 newtons up. It's a force normal of 0.5 newtons. What's dealing the 0.5 newtons? The ground, and who's feeling it?
The block.
The block A. Very good. All right, so we have a constant velocity. With a constant velocity, we're going to call this T. Okay? I'm going to call this F, the floor. T is going to be like tension if we have a rope if we need it. We have a constant velocity, so we are going to have a force applied moving to the left, because notice that the hand is moving to the left. So we have a force applied to the left. And this is like our hand is going to be F right here, okay? So we're going to call that applied F. Feeling that is A. We also are going to have a force of friction and a force normal. So backwards, we're going to have a force normal. And that normal force is going to be dealt by B, felt by A, because they're touching each other. And we're going to have a force of friction. Friction is going to come from T, and we'll feel it by A. T is the ground here, okay? We'll call that the table. That's a T for table. And F is for finger. Does that make sense? Why I picked those? Okay. Yes.
We have to say like things that are like the names of our like for a table. Like
If you guys might have used ground or something different, that's fine.
yeah, I put H for hand.
Yep, that's fine.
Alright.
All right. Block B. Block B is going to have gravity. How much of gravity is it going to be? 0.5 newtons. Who's dealing the gravity?
Earth.
Earth. Who's feeling it?
Black.
Block B. What about a normal force? Is it going to have a normal force?
Yeah.
These are the same too. It is going to have a normal force. Dealt by the table or the ground, we'll say. Felt by B, and that's 0.5 newtons. It's going to have friction backwards, felt by the table, or dealt by the table, felt by B. And it's going to have a normal force pushing on block A because they're connected. Felt or dealt by A, felt by B. Our similar or our Newton's pairs are this force normal with this force normal. Do you guys see that? All right. We also have to look at the system. I know this is kind of a hard one, so it's okay. This is one we haven't really looked at yet. So system. As a system, we have block A and block B together. They're going to have a force of gravity downwards of 1 Newton. They're going to also have a force of normal upwards of 1 Newton. We're going to have an applied force to the right that is going to be same as our force of friction. Or sorry, applied force is to the left, force of friction is to the right. They're going to be the same length because as a system, it's moving at a constant velocity. Does that make sense? Okay. I know that was a hard one. I would never give you one this hard on a test. Does that sound fair?
Yeah.
It's a hard one. Gravity. Okay. This is a hard one. I'll get these zoomed in on really good for you guys. All right, so let's kind of go through this again. We've got block A. We have a force of gravity down, which is 0.5 newtons, dealt by Earth, felt by A. Equal to that, we have an upward force of normal of 0.5 newtons, dealt by the ground, felt by A. Because the finger is putting a pressure on there, we have an applied force from the finger, felt by A. It's longer because it's accelerating. Because block A and block B are pushing on each other, we have a normal force, dealt by B, felt by A. And we have a force of friction going backwards, dealt by the table, felt by A. Looking at block B, we've got a gravitational force, dealt by Earth, felt by B. Normal force, dealt by the ground, felt by B. We have normal force from block A pushing to the left, because block A is on the right side of it, so it would be a force pushing to the left, dealt by A, felt by B. And a force of friction, dealt by the table, felt by B. Our pair is the normal force where block A and block B are touching each other. They're normal forces. Looking at the system overall, force of gravity down is equal to the force of gravity, the force of normal. Applied force is going to be going to the left, and it's going to be longer than the friction force going to the right because the system is accelerating. Make sense? Easy to recap it? Okay. Let's look at our last letter, letter C. This time our finger's on the opposite side. We've got block B bigger than block A, and we have constant acceleration to the right. So we'll start with A. I'm just going to do these. Ooh, hey. Oh, I did that. All right, we'll start with letter A. All right, A has a force of gravity, correct? How much is A's force of gravity?
0.5.
0.5, very good. 0.5 newtons. What about normal force? Is there a normal force? Upwards. How much should the normal force be? 0.5 newtons, very good. Okay. Obviously, gravity dealt by Earth, felt by A. Force normal, dealt by the ground, felt by A. Where's the force normal going to be for A? B is on its left side, but remember, B's force is pushing to the right. Does that make sense? So because B is on the left side, but its force is pushing to the right, our normal force for B, our F normal, is actually going to be on the right side because B is pushing from the right onto A. If we have any friction, that would be on the left. It would be pushing opposite of our direction that we're moving. And that would be a force of friction if we have any in this instance. Obviously, it would be dealt by the table, felt by A. Okay. Notice this one doesn't have an applied force this time. That's because the finger in this instance is pushing on B instead of A. Do you see that? So block B. How much is my force of gravity for block B now? This time it's 1 Newton. Dealt by Earth, felt by B. Which also means its normal force is going to be bigger. It's going to be 1 Newton. Dealt by the ground, felt by B. The finger's pushing on this one. In what direction is the finger pointed or pushing? To the right. So our force applied is going to be to the right or to the left? I'm pushing this way. It's going to go to the right. It's accelerating, so we know it needs to be longer. So we've got an applied force. This one's from the finger, felt on B. If we have, we're going to have a normal force. What direction is the normal force? Because remember, the normal force is from A. So A is pushing what direction on B? It's pushing to the left, right? So our normal force is going to be to the left. We'll say force normal. This is A on B. And if we have any possible friction, it would be also to the left, if we had any. Looking at my third law pairs, what is my third law pair in this instance? Force normal, very good. Force normal. So right here and right here. Good job today, guys.